Hey, Luce, this is Dave. I'm just recording a little screen capture here to give you a couple tips on creating meshes for printing. One tool that you're going to want to download is called MeshLab. MeshLab is great for getting statistics on your meshes, and also for fixing up things that go wrong. So I've got MeshLab open here. It's a free program. You can just Google it. I'm going to go ahead and open the mesh that you sent me. So I do File, Import Mesh, and select the STL file. And the first thing it's going to do is say that there's a problem. It asks me if I want to unify duplicated vertices. That means sometimes when you create a polygon mesh, the vertexes aren't attached to one another, and so that's one thing that you want to do right away. And so we're going to go ahead and say OK to unify those duplicated vertices. It's going to crank through that, and there's the file. And so the first thing you'll notice at the very bottom, you'll see how many vertices and faces are in this file. There's 1.2 million vertexes and 2.5 million faces. That's 2.5 million polygons, and that's usually a little too much. A lot of online places like Shapeways will only accept files up to 1 million vertexes, and if I go over 1 million vertexes in my print software, the object it starts to go to wireframe, and I can't really see it very well. So we should try to stay below 1 million if possible. If I zoom in on this, you can see it doesn't look very high resolution. It looks fairly boxy, but there's hidden geometry in here, and I'll show you that when we get into Cinema 4D. But I just wanted to show you this is a way to open up the file and do some preliminary looking at how many vertexes and faces there are. There's also a lot of tools for fixing up meshes if there's a problem with them. Under this Filters tab, there's a couple of things you can do. There's under these Cleaning and Repairing, you can find non-manifold edges, for example. That's edges that aren't connected to anything. This is a thing that will not allow printing to happen. It allows you to do what we just did, remove duplicated vertexes. And it also lets you, there's some nice tools in here for remeshing. If you have too many polygons and you want to subdivide it, there are some good tools here. And so I'm not going to get into that now because I don't think that remeshing is the thing to do with this. But I just wanted to show you MeshLab and how to see how many polygons you have in your sample. I'm going to go over to Cinema 4D now. This is the program that I use to get around and see what's what in these meshes. So I'm going to open that same file up in Cinema 4D, and so one thing I want to point out here is that it asks me, when I open up the file, it asks me what scale to use. You had asked me about whether this comes in as the right scale, and it's hard to tell because STL files do not they can't carry scale information with them. So when you export an STL file, the program you're using will usually ask you what scale to use, and then you have to tell me what scale you use to export so I can choose the same scale on import. And so there's no way for that to carry with. So I've found with this that a scale of 10 centimeters worked out just about right. If I put this at 1 centimeter, it was too small. If I put it at 1 meter, it was too large. So I'm not sure which scale you use, but if I import this at 10 centimeters, it imports the model at about 10 centimeters. So I'm going to go ahead and select that. And there's the model. Now, one thing that I notice right away is that part of this isn't attached. This isn't a big deal, we can get rid of it, but this is something when you're making your models you might want to keep an eye out for. If you look down to the lower right here, there are a couple of pieces that are not attached to the model. They're just hanging out there. That will print, and it will create some extra things in the powder in the printer. The other thing to notice here is that this is pretty thin. There's some pretty thin parts off on this edge. Now when you back out and look at how small those are going to have to be, those are not going to be able to support themselves. And I'll show you how to measure that in Cinema 4D. There's some rules about how thick things can be and be able to support themselves. A good resource for finding out some information about this is on the website called Shapeways. If I go over to shapeways.com, under the Make and Sell tab, they have some tutorials. So Shapeways.com is a company that does 3D printing from your files, and they print with a lot of different materials, and they have some really nice tutorials about how to do some things. And one of the things you'll see here is how to reduce polygon count with MeshLab, for example, what I was just showing you. So if you click this, it will show you, here's where MeshLab says that they don't accept anything higher than 1 million polygons. And they have a nice demonstration about how to use MeshLab to simplify models in MeshLab. Okay, if we go over to the materials section under making products, there's a list of the materials they use. Now the printer that we have is this one that prints in what they call full color sandstone. And if you click full color sandstone, it will give you some guides about about what your minimum thicknesses should be. So here it's saying that the minimum unsupported wall thickness is 3 millimeters. So you can't have less than 3 millimeters if you have something that's extending out into free space. And a supported wall can only be 2 millimeters. And this is a little, you can in a pinch go a little bit lower than this, but this is a good guideline. And now I'm going to show you how to measure this in Cinema 4D. Okay, so we want to try to make our wall thicknesses a certain thickness, and our unsupported walls a certain thickness. So I'm going to go back over to Cinema 4D, and so I've got this set up right now so that it is, if I select my object and look down here at the size, you'll see that it's 9.9, basically 10 centimeters on a side, and this that's about 4 inches. And so I don't really want to be printing this much larger than this. In fact, I can't print it much larger than this. The maximum depth in our printer is 5 inches. So this is about as big as I'm gonna print this object. And so I've got it scaled correctly so that if I make some measurements on here, they'll be correct. And in Cinema 4D, and I don't know what program you're using to edit these things, but in Cinema 4D there's a tool called the Measure tool. So now I've got this scaled the right scale. If I go over to Tools and select Measure and Construction, it will let me drag out a measurement on this right on my screen. Now when I do this, if I if I click once, it brings one dot, and if I hold the Shift key down and click again, it will let me make a measurement. Now, when I do this in the perspective window, it doesn't really work, because if I rotate this drawing around, you'll see that, oh, I guess it did in this case. But sometimes this is tough to do. So now I have dragged out a measurement. This is 0.3 centimeters here, so that's 3 millimeters. Now, if I do this to the thickness of this, a measurement that is now 0.06. So that's 0.6 of a millimeter is how thick that is, and that's too thin. So we need this to be like 3/10 of a millimeter, or 3 millimeters, or 2 millimeters for this. This would be considered a supported wall, so this should be 2 millimeters. So we're well below that, and especially these little points that come out here will be way too small. So that's a way to measure. Now, I'm not sure if you're using the same program, but whatever you use, if it's Lightwave or Maya, there'll be a way to measure that. So scale a thing up to your printable size, and like I said, our build bed is sort of like 10 by 10 by 5 inches. So nothing higher than 5 inches. So that's going to be an issue. Those parts will probably fall apart when we pull it out of the printer. Some of these might hold up, the ones that are inside here, because they're really well supported. However, it would be best to thicken these all the way around. Now, let me use this to show you the inside of the model, and this is where where the extra geometry is. So I see a couple of issues with the geometry. All of these tubes have many more faces than they need. They're all very convoluted, and if these were smoothed out, we wouldn't see any degradation of the image at all. There's just a lot of extra polygons in here in general. But also, if I go inside of this model, and I'm going to try to rotate this around in an orientation that will let me do this. Let me rotate this. Let me just rotate this around. So I'm rotating it around so I can see this these large circular areas, because where they intersect, you can see that there's lots of extra geometry on the inside. Now watch what happens when I zoom in. So if I keep zooming into this area, I start to go inside of the model. And once I get inside the model, you'll see that there is all kinds of layers inside of here. So I'm inside of this, and I don't know if you can notice this, but there are many layers, shells on shells on shells on the inside of this model. And some of these are insides and some are outsides, and it's not clear how this is going to print. Some of these will be solid objects floating inside of other solid objects. Some will be loose powder. But this also is the reason why there's so many polygons in this model, is that it's all of these shells inside of shells. And I have a feeling that this is going to prevent this from printing. If as I zoom in through the model, you can see all of these extra shells. Now, I don't know if there's a way to get rid of them. There's a way to do it by hand, but it would be very time consuming in this because there are so many of them. So, zooming out now. So that's what I see with this model. It looks great. It's really a beautiful model, but I have a feeling that it won't. Even if it printed, some of these very small features would break off easily, and some of the features on the edges also. So let me know if there's anything I can do. I don't know what program you used to create these. I'd be happy to take a look at it and see if I can troubleshoot how to eliminate some of the internal structure on here. But at least you have some idea of what the limitations are of the printer, and I hope that this helps. I'll be in touch. I'll talk to you soon. Bye-bye.